Let's have a look at question 2 now. So if 9 employees are chosen at random, the probability that their average age is below 35 years is going to be the following, 0.06, so 6%. Now, this is the data that we have. It's the same question with the employees in the insurance company. This is how the distribution looks like. And what we're interested in, we want to find out the proportion of employees that are going to have an average age below 35 years when they are taken at random. 9 people taken at random. Now recall this, we had this in previous videos from last assignment. Whenever we want to deal with probability or proportion, we want to convert the regular distribution, in this case it's a distribution of ages, into the standard normal distribution, because the standard normal distribution gives us the probabilities that we're looking for. So that standard normal distribution is the z distribution, meaning we want to convert this data, the 35, into a z value. How do we do so? So let's see what's going to be slightly different than before in this question. The z value is going to be the difference between the sample mean that we're interested in from the population mean divided by the standard deviation over square root of n. And notice what's different. What's different is that now we're not dealing just with an observation of x and how much it differs from the mean in terms of standard deviation. We're interested in how much the sample average, x bar, differs from the population mean in terms of the standard error. This is called the standard error. Standard deviation divided by square root of n is the standard error. And it's the same logic as before, it's just now we're dealing with a different sampling distribution. We're dealing with the sampling distribution of the sample mean. Now, this might sound a bit odd, so I'm not gonna go too much into that in this video because it's going to be too much information. There are videos in this playlist which explain the difference between standard deviation and standard error. The difference is minor, right? It's something mathematical that you have to understand, but the intuition is the same. How much does one differ from the other in standard units? In one case, when we're dealing just with one observation, we compare it relative to the standard deviations. How many standard deviations away is one observation from the population mean? In this case, how many standard errors is the sample mean away from the population mean? Hope this makes sense. With this logic in mind, we can convert our z value to translate it into the z distribution. So our z score is going to be the difference between the sample mean, and we're interested in this sample mean of 35 years. So it's going to be 35 minus the population mean, which is 38 years over here. 35 minus 38 divided by the standard error. And we said the standard error is going to be the standard deviation of 6, right? It's given to us. 6 divided by the square root of the sample size, square root of 9. Divided by the square root of 9. Well, if we work out the math, that's going to be 35 minus 38. That's minus 3 divided by 6 over 3. That's 2. Minus 3 divided by 2 is equal to minus 1.5. Minus 1.5. Now let's translate this data into a new distribution, the standard normal distribution. We're doing it right now. So this is going to be our standard normal distribution z with the mean of 0, right? With the mean of 0, symmetrical around 0. Now we're interested in the proportion of having values up to minus 1.5. So minus 1.5 would be somewhere over here. And we're interested in this tail. We're interested in this tail over here. So if we check the z distribution, the z table, the probability that the z value is less than or equal to minus 1.5 is equal to 0.0668, which is the same as 6.68%. That is the proportion of that tail, meaning that the probability that the average age of a random sample of 9 people is below 35 years is going to be equal to 6.68%. That's what we just proved. Hope this all makes sense. And once again, the main thing to understand the difference here is this. The difference between this z value and the difference of this z value, because they are the same, except that in one case we're dealing with individual observations, in another case we're dealing with a sample average of more observations. Hope this makes sense, and we are done.